Hello, everyone, and welcome back to another episode of Earth's Place in the Universe. Now, if anyone asks you about the universe, basically it consists of everything in space. And when I say in space, I'm talking about the stars. We had a video about those. We're talking about galaxies. There are billions of galaxies in the universe. We're talking about the solar system, and we're only going to talk about our solar system and all matter and energy. So within the universe, you have dark matter and you have dark energy. And one of the things you have to remember about the universe is that it is very large. Now, on the task test, you have to know how the universe formed. How did it came into being? And that is described by the Big Bang Theory. So the premise on the Big Bang Theory is that billions of years ago, our universe was a very small, dense point of energy and matter. And all of a sudden, it exploded. And this is what the astronomers call the Big Bang. What happened is when it exploded, it sent the universe flying out at incredible speeds. Astronomers estimate that the universe began 10 to 15 billion years ago. Now, a lot of my students always say, well, how do they know that? Well, it's an estimate. There are two factors here that gives us the age of our universe. The astronomers, they looked at the mass of the oldest stars and estimated that the universe is between 11 and 18 billion years old. So that wasn't really accurate. It gives an estimate like where the universe, the age of the universe falls into, between 11 and 18 billion. However, another estimate is based on the expansion rate of the cosmic radiation levels. We're going to talk about that in a few minutes. And that places the age of the universe about 13.7 billion years old. And that 13.7 billion years is usually what you see in most textbooks. Now, in a lot of textbooks, the Big Bang Theory, they talk about it as an explosion. And you just heard me said it was a huge explosion. Well, scientists believe that it wasn't really an explosion, it was a rapid expansion. When the universe expanded, you had two elements being created, which was hydrogen and helium. And I spoke about those when we talked about the formation of stars. And remember, I told you that hydrogen is the fuel of stars. And as stars age, the hydrogen gets converted to helium. Also, what can be found in the universe is small amounts of lithium and beryllium. On the task test, they always ask about evidence, like what evidence do you have that the Big Bang occurred? Now, one evidence is cosmic background radiation, and this is faint energy or heat radiation that was left over after the explosion. Now, this was discovered accidentally in 1964 by Arnold Penzias, probably saying his name wrong, and Robert Wilson. And they built this antenna to do research on radio signals that were being reflected off satellites. And they noticed this noise. They thought that the noise that they were hearing was actually radio interference from New York City. But eventually, it was recognized that it was radiation from beyond the Milky Way. So the Milky Way is the galaxy that we are in, and that faint noise that they were hearing was the cosmic background radiation, which is still there in space today. Another piece of evidence is the expanding universe, which implies that our universe was small, and when it exploded, it therefore start to increase in size. Now, when they say it is increasing in size, it doesn't mean that the planets are increasing or the stars are increasing. It just means that the space between the galaxies are increasing. And another way to think about it is if you're on Earth, everything is moving away from Earth. So all the galaxies are moving away from Earth. Another term that we use is called redshift. So redshift means that everything is moving away from Earth. And if you look on a spectrum, it means that everything is moving towards the red side of the spectrum. So it's a redshift of wavelengths of light from distant galaxies. And that's how we know that the Big Bang occurred. So two pieces of evidence. Always remember cosmic background radiation, the universe is expanding, and then red shifted. Everything is moving away from Earth. Now, our universe is structured, and when I say that it's structured, it means that it has a characteristic form, it has a composition, and it has an arrangement. So within our universe, you have stars. So when the Big Bang occurred, the first thing you get forming were stars. And then after that, you get the galaxies being forming, and then our solar system then can be found in one of the galaxies, which is the Milky Way. So when anyone say the structures in the universe, think of stars. Stars are structures, galaxies are structures, and our solar system is a structure. And they like to compare them. So always remember the universe is the biggest, right? So then next you would have the galaxy, and then next you would have the solar system. So the solar system is within the galaxy, and those two things are within the universe. So let's talk about our solar system. So when anyone says the solar system, we know they're talking about the planets. Also, they're talking about the stars. Also, remember the sun is a star. Also, they're talking about moons. Remember, Earth has one moon. We have comets. They don't come around too often. And basically, when we say the solar system, it's really any object that is orbiting the sun. So you could have asteroids. Those are objects in our solar system. Now, our solar system is located in the Milky Way galaxy. Now, let's talk about galaxies. Now, a galaxy is basically a large collection of stars, gas, and dust. Now, when I say a large collection of stars, I mean large. I mean billions of stars. I don't mean like 5 stars, I mean billions of stars. Now, that cloud of dust and gas is called a nebula. And we talked about that when we were talking about the formation of stars. The word nebula is actually Latin for cloud. Now, some of these nebulas glow by themselves. Others absorb light and hide stars. You have others that reflect starlight and creating very awe-inspiring images like what you see before you. And some nebulas are regions where new stars are formed. Now, there are 3 different types of galaxies you have to know. There's spiral galaxies, elliptical galaxies, and irregular galaxies. So a spiral galaxies, these are a nucleus of bright stars and 2 or more spiral arms. So spiral galaxies appear to have a bulge in the middle, and then it has arms that spiral outwards like a pinwheel. And those spiral arms is where you can find many bright young stars as well as dust and gas. Now, notice if you have dust and gas, you're going to have nebulas. So in spiral galaxies, you're going to find nebulas. Now, in a spiral galaxy, you have relatively few new stars forming in the center bulge. So in the center, this is where you're going to find more of the older stars. So the Milky Way, which is our galaxy, is a spiral galaxy, and it is one of the billions of galaxies in the universe. Next, you have elliptical galaxies. Now, these are spherical or flattened disks. About a third of all the galaxies in the universe are just simply massive blobs of stars. When I say that it's an elliptical, I mean that it's shaped like a football. Now, when you talk about elliptical galaxies, they have very bright centers, so the center is very bright. You don't have a lot of dust and gas. Therefore, you don't have nebulas. So because there is so little gas and so little good dust, you're not going to have any new stars forming in an elliptical galaxy. So basically, you're just going to have old stars. Whatever is there is there. That's all you have. Last but not least, we have irregular galaxies. And all this means is that it really doesn't have a definite shape. Now, when Hubble first classified these galaxies, he couldn't find a name. He didn't want to call them the leftovers. So he called them the irregulars. So irregular galaxies are galaxies that do not fit into the other classes, so they're not spherical or they're not elliptical. So as the name suggests, irregular, none of them look the same. And what he found out is that these galaxies did not have enough time for the gravitational forces to form a spiral or an elliptical galaxy. These are the youngest galaxies in the universe. Okay, with all that knowledge, let's look at some task-like questions. So this is the first question. It says, which evidence best supports the Big Bang Theory? You can pause, look at the answer choices, and choose your answer, and then unpause. Is it A, rate of rotation of the sun, B, existence of cosmic background radiation, C, uniform radioactive decay or uranium-238, or is it D, separation of Earth's interior into different layers? I told you I actually gave you three evidence. So one was cosmic background radiation, the second was that the universe is expanding, and the third was redshifted, meaning everything is moving away. So you should see your answer right here, which would be B, the existence of cosmic background radiation. Let's look at question 2. So here it says the red shift of light from distant galaxies provides evidence that the universe is. Remember we talked about the red shift, and we said that the red shift means that everything is moving away, or you could think about if everything is moving away, then it is expanding. So is it shrinking only, expanding only, shrinking and expanding in a cyclic pattern, or remaining the same size? So again, when we talk about redshift, we mean that everything is expanding. So they're moving away from Earth. Question 3 states, compared to our solar system, the universe is. So they're comparing the universe to the solar system. Number 1 says younger, smaller, and contain fewer stars. Number 2, younger, larger, and contain more stars. Older, smaller, and contain fewer stars. Older, larger, and contain more stars. If we're talking about the universe, remember in my first slide or second slide, I said that the universe is very, very large. Also, the universe is very, very old. The universe formed first and our solar system came later, which means that our universe is older. Now we know that it is older, it is also larger, and it contains many stars. Now let's look at this question. It says the diagram below represents the spectral lines from the light emitted from a mixture of two gaseous elements in a laboratory on Earth. So this is our spectral lines. This is blue and this is red. If the same two elements were detected in a distant star, and here's your keyword, that is moving away from Earth, how would the spectral lines appear? So remember, when anything is moving away from Earth, we say that it is red shifted. Now, 1 says the entire set of spectral lines would shift towards the red end. That is correct. So remember, when anything moves away from Earth, it means that it is red shifted. 2 says the entire set of spectral lines would shift towards the blue end. That is not true. There is something called a blue shift, and a blue shift means that everything is moving towards Earth. We don't really talk about the blue shift. We always talk about red shifted. Your answer is not 3. The spectral lines of the shorter wavelengths would move closer together. and it's not 4, the spectral lines of the longer wavelengths would move closer together. So always remember, anything that's moving away from Earth is considered redshifted, or it's moving towards the red end of your spectrum. Here's another spectral line question. The diagram below shows the spectral lines for an element. So notice here they didn't use blue, they used violet, and here's red. These are your spectral lines here. And they want you to choose which diagram best represents the spectral lines of this element when the light is observed coming from a star. And again, notice the keyword, moving away from Earth. Now, anything that's moving away from Earth is redshifted. And if it's redshifted, it means that it's moving towards the red end of the spectrum. So these lines here are moving towards the red end of the spectrum. If we look at A, that is not our answer because the spectral lines did not move. Let's look at B. Those lines are over here. Both of them, they're moving towards the red end. So your answer is B. Your answer is not C. Notice that this is moving towards the blue and this is moving towards the red. Your spectral lines must move together towards the red end. And then here, your answer is not D because notice the line is moving towards the violet, which we will consider that blue shifted because it means that it's moving towards Earth. I want you to try these 2 questions. You can pause, you can read them, choose your answers, and then unpause. These 2 questions were on the recent Regents exam 2021 that was administered in June. So for question 1, scientists who proposed the Big Bang Theory were attempting to explain. I hope you chose number 1. The origin of the universe. Number 2, here it talks about the red shift in light from stars located in very distant galaxies suggests that these stars are, and remember when we say red shifted, it means that it is moving away from the Milky Way galaxy. I hope this lesson has been helpful on Earth's place in the universe. If you like the content, please like, please share, please subscribe, and good luck on your TAS Science exam.